this lecture is about the control system evaluation. We are already well aware about the feedback control system as well as the fundamental of the control system. Now the question is why to evaluate and how the evaluation is required. So a process control system is used to regulate the values of some process variable. This thing we have already considered that any of the process control system, there is a need to regulate some of the process variables. So that process may be the controlled variable. It may be a feedback variable which is going to the error detector. So when such a system is used, is it natural to ask how well it is working? This is very important question in all the time. So it is not very easy to answer that whether your automatic control system is working very well, because it is difficult to adjust the control system to provide different kinds of responses to an error. So what is happening when any of the control system is working, the chances of errors are always increase as due to the disturbances in the system or many other factors are there. So this presentation discusses some methods for evaluating how well the system is working. So let's see the some of the objectives of the control system. So if you consider any of the examples, so in all the example of the control system, they have some objective. The objective of the control system is to make the error exactly zero. Ultimately, the feedback control system is running very close to the error signal. It is always, you know, the if the for example, you are controlling the speed of a car is one example. So if you want to set the speed of a car at 60 kilometer per hour, so ultimately you are measuring the speed of a car regularly in very fast manner, because the car itself is moving very fast. So your set point is 60 kilometer, but your car may be moving at 61 or 58 or 65. So what is happening here? So there is a generation of a error between the set point and the feedback signal which is coming from the sensor which is connected to the wheels of the car. So in this way, the objective of the control of speed of your car is to make the error exactly zero, but practically it is very difficult to keep the error at a zero. So in the perfect control system, there are the following three main requirements are there. One is that the system should be stable. Another is that the system should provide a best possible steady state regulations. And the third is the system should provide the best possible transient regulations. So these three objectives are very important in the feedback automatic control system or any of the process control system. The system should be stable. So let's see the how the system is, what is the meaning. The purpose of a control system is to regulate the value of some of the variables already told. So in the absence of a control system, it can cause the process to become unstable. So you just look on the diagram on the right side of this presentation. So you will see the on the bottom side, it is the graph is displayed in the time domain. So on the bottom side, the time t is changing, and upper side the output ct is there, and small r is your set point or a reference point. So this dotted line is showing you some of the reference point, and the black line, which is oscillating line, is showing you the actual response of the system. So in the system, the when the system is not supposed to be turned on, there is a some variation is there in the controlled output, and that variation may be the oscillating, or it may be smaller, it may be the larger. In the absence of such a control system, it can cause the process to become the unstable. Figure shows prior to the tuning on a control system, the controller variable drifts in a random fashion and is not regulated. So if you are not switching on the control system, the error, the output of the system is not supposed to close to the set point. It may be fluctuating. So after the control system is turned on, the variable is forced to adopt the set point, and it is the it is, you know, the you will see that whenever in the graph, when the control system is supposed to be turned on, the graph is almost stable. And even then, notice that after some time, however, the variable begins to exhibit the growth oscillations uh, of the value, that is an which can be considered as instability. So this occurs even though the control system is still connected to the operational. So this is quite happening in the practical control system. Even if you have added the controller to the process, even then certain oscillations are there. So these oscillations may be due to several reasons. So these oscillations may be the regular disturbance in the outside. These oscillations may be the some of the inherent the errors inside the controller. So these oscillations may be drift. So one of the example is that some of the electronic instrument like the sensors, like the other controllers, so the internal temperature of these electronic devices generally increase whenever they are switching on for the very longer duration of a time. So such type of the drift, such type of oscillations are quite possible. But your controller is also quite adaptable to such type of the disturbances, and controller will also try to control such type of oscillations. So the first objective then is to control the system must be designed and adjusted so that the system become be stable. So this is the value of the stability of the system. The system which you are controlling should be stable. There should be very less oscillation, where should be very low deviation from the set point even over the longer duration of a time. So the system should be the stable. The second objective or the requirement is that the steady state regulation. So again in this diagram, so you will observe that the graph is a time domain and output is having CT, and the dotted line is showing you the set point line. And whenever you are switching on the system, okay, there is a transient state in which the controller is taking the action, and the final control element is trying to stabilize the process, and the process start going on at a steady state. Okay, so this steady state regulation is very important. The if the system is supposed to be underdamped or overshoot, so such the conditions may be violating the control system. So the objective of the best possible steady state regulation simply means that the steady state error should be minimum. So this error, you are already aware that the error is between the set point and the steady state of the process output. So generally when the control system is specified, there will be some allowable deviation about the set point. Okay, so there is always whenever you are design a system according to the physical parameter of the system, you are already as an engineer aware that how much deviation is a process is a possible. So that is the sometime the margin is always given. So if you are again considering the example of a speed control of a car, so as per the specification of a car having its own momentum, its own the, so whenever you are giving the specification of automatic car, you will said that you can control the speed up to 60 kilometer with plus minus 1 or 2 kilometer. So plus and minus is your the tolerance, or as well as the allowable deviation about the set point. Similarly, if you are controlling a temperature of any of the system, so if the temperature is supposed to be can be deviated by 1 degree plus and 1 degree minus, the chances are always there because of the process lag is there, the controller on the some problems are there. So practically some deviations are there, and these deviations are generally considered as a allowable deviation. So this means that the variation of the variable within the band are expected, and they are many times is acceptable in many of the process. So external influences that tend to cause the drift the value of beyond the allowable deviations are corrected by the control system. So the tendency of the control system is always to regulate the steady state parameters of any of the control system. This is the objective. Similarly, there is one transient regulation is also required. What happened to the value of the controlled variable when some sudden transient the event occur that would otherwise cause a large variation. So what is happening here? So if you are controlling the any of the process, so what you are doing, so you may be suddenly changing the set point. Okay, so initially assume that you was controlling the temperature of a bath, and inside the temperature the set point was 70 degrees centigrade. You suddenly change the temperature from 70 to 90 degree. So now the moment you change the 70 to 90 degrees, so there is a large fluctuation, because you are switching on the heater, you are switching on the steam, you are opening the valve of a steam, and the internal temperature is having the dynamic, the properties it is adopting at the time, and there is a sudden fluctuations. Then the question is, what happened if such type of the sudden transient events are occurring into the process? So these transient events can occur by the different ways. One is if the you are changing the set point suddenly, then such type of fluctuations can cause the transient the variation. Or if the any of the other parameter in the form of a disturbance is there, which is suddenly came, can also change. So again, considering example of a temperature control, if you are controlling the temperature and suddenly the inlet fluid whose temperature you are controlling is earlier the normal temperature at the inlet was around 40 degree, and right now it is going to be minus 20 degree. So it is sudden fluctuation in the process, and in that case it such type of the responses are the transient response. So the transient influence is sudden change of some of the process variable. The controlled variable depends upon the process variables, you already know. If one of them suddenly change value, the controlled variable may be driven to the change also. So the control system acts to minimize the effect, and this is called the transient response. So the transient response of your designed process control should be very much fine, so that it should be immediately stabilize the system in minimum duration of a time. Now what happened if the system is not to be the solid system, the design is not supposed to be much good, so there may be large oscillation on the controller side. So such type of the oscillations can be removed by using the system. So these two diagrams you have already gone through your graduation course, is how the response is there, what parameters are there. So this is again the time domain. The graph is shown in the time domain, and in this graph it is showing that what is the settling time, how at what time the your process is settling down, and it is going on a steady state with the minimum error. Similarly, the delay time is also mentioned here. So in this there is some other parameter you have already know that it may be the overshoot, it may be under damp. The tolerance band is also given here. So these type of the responses in the form of the transient as well as steady state are the objective. Now next is the evaluation criteria for the transient response. So now how you will evaluate that the system is having the transient response, and how you will evaluate the steady state response. So you already gone through the basic control engineering subject. So in that control engineering subject, you already know the mathematical relationship of the steady state control of any of the process. If you are giving some set type of a signal, that signal may be uh, it may be a step signal, it may be a ramp signal. So your system will behave to these signals in their own manners, and in that case you have to evaluate what is the response of your the system which you have designed for the control. Now there are the different evaluation criterias are there. In the transient response, you will find out that the how much time it is taking to come to the steady state. So by tuning the system, by analyzing the system, you can give the different set of the signals. You can change the value from the old reference to the new reference immediately, and you will evaluate that how fast that process is going to be rectified. So if your system is not to be well, what will happen? This suddenly fluctuate, and there may be the maximum, the errors are there, and the settling time will suddenly be increased. So these type of the evaluation can be done by using the both by mathematically, or can be done by using a simulation method on a MATLAB, or some other software tools are there. Similarly, the another evaluation criteria is by using the analog and a digital processing. So right now, due to the advances in the software technology, due to the advances in the algorithms, so one can use the analog and digital processing of the signals. So in the past, the functions of the controller in the control system were performed by sophisticated electronic circuits. So the data were represented by a magnitude of the voltage and current in such a system. So that was referred as a analog processing, and we have already discussed about the limitations of the analog processing. And analog processing, the as compared to the digital processing, lot many advantages are there with the digital processing. So modern control systems are employed with the digital computers to perform the controller operations. So in computer, the data are represents in the form of a binary number, in the form of a digital information consisting of a specific number of a bit, which is very crisp and very smaller. The segment of the information can be analyzed. So this is refers to the digital processing. So both the digital and analog signal processing techniques can be used to analyze the behavior of the control system. So in addition to that, many other methods are there with which the evaluation of the process can be done by using the system. So thank you very much. I hope you understand the evaluation criteria of any of the feedback control system.